Alright, number 7. Violet has 5 coins in her pocket. All of the coins are nickels or dimes and are worth a total of 40 cents. The system shown below represents this situation. How many of each type of coin does Violet have in her pocket? We are already given the system of equations in terms of nickels and dimes in N and D, but it may help us to graph it if we turn it into X and Y. So let's let N or nickels be X and let D or dimes be Y and rewrite them. So this first one, it will be X plus Y equals 5. And we need to put it in slope-intercept form so it's easier to graph. So we can subtract the X, and that gives us Y equals negative X plus 5. So there's our first one. We'll graph it in a second. The second one, we're going to replace N with X and D with Y again. So X plus 2Y equals 8. Now let's get the Y by itself. So I'm going to subtract the X. That gives me 2Y equals negative X plus 8. Let's get the Y by itself. We divide by 2. And we have Y equals negative 1/2 X plus 4. Remember that negative X over 2, we know there's a 1 in front of it, so that's the same as negative 1/2 X. So let's graph these. We know our X-axis, X is going to be the number of nickels because we replaced N with X. We know our Y-axis is going to be the number of dimes. And now we can graph it. So for the first one, we have Y equals negative X plus 5. We start at 5. We go down 1 over 1, down 1 over 1, down 1 over 1, etc. Alright, so let's go ahead and draw our line here. Now for this function, is it going to be discrete or continuous? This one will actually be discrete because we can't have partial nickels or dimes. But I'm still drawing a line because it's going to help us. It'll just make it easier to compare. So let's go ahead and write ourselves a note that this is discrete. And we know that, but we're drawing a line because it'll be easier for us. Now, second function, we're going to start at 4 and go down 1 and over 2, down 1 over 2, down 1 over 2, down 1 over 2. Also notice that I'm not extending the lines past the axes because we can't have negative nickels and we can't have negative dimes. Alright, so we have our 2 lines. We ultimately want to know how many of each type of coin does Violet have in her pocket. So that means we need to find the solution to this equation, to this system of equations. So what is my solution when it's graphed? It's where they meet. So what's my solution here? My solution is 2, 3. And we want to put this in context. Whenever we have a word problem, we're going to write our answer in context. So we want to know how many of each coin does she have? Well, she has, our 2 is our X value. What does X stand for? Nickels. So she has 2 nickels. And our 3 is our Y value, so she has 3 dimes. 2 nickels and 3 dimes. Make sure that you put your answer in context. Okay? So there's our first one. Let's look at the second one. Number 8, Video Club A charges $10 for membership and then $4 per movie rental. Video Club B charges $15 for membership and $3 per movie rental. For how many movie rentals will the cost be the same at both video clubs? And then what is the cost? Write a system and solve by graphing. So we are actually going to start by writing the system and solving, then we'll answer that question afterwards. Well, to write our system, let's look at the information we're given. The Video Club A charges $10 for membership and $4 per movie rental. That sounds like I'm given a slope and an intercept. So what am I paying over and over here? I'm paying $4 per movie rental. That's slope language. So if I write this in slope-intercept form, it'll be 4 is my slope, so 4x. 10 is my intercept because I only pay it one time. So y equals 4x plus 10. Video Club B charges $15 for membership and $3 per movie rental. So let's put that in slope-intercept form. We're paying the 3 over and over, so that's 3x. And we're paying the 15 for the membership, so 3x plus 15. Let's talk about what x and y stand for. Let's define our variables. X and Y. So what is X in this case? We're paying $4 per what? Per movie rental. So X is going to be the number of movie rentals. And then our Y value, I'll just put the Y right there. What does Y stand for here? Well, we have 4 times the number of movies we rent. This is money we're paying. 10 is money we're paying. So Y is going to be the total cost. All right, the reason I have tables set up here is because we are going to graph this using tables. So let's go ahead and label this graph together and scale it, and we'll make our tables. So for the x-axis, we're just going to label it by ones. On the y-axis, we can't use ones. If we think about this logically, we're going to have to start at 10 for one of them, start at 15 for the other, and we have to use our slope and go up and over until the lines cross. So we are going to need to count by 5s. Once we scale our graphs, we need to actually label them. What does the X stand for here? We said it stands for the number of movie rentals. And then what does Y stand for? It stands for the total cost. So I know there's not a ton of room there, but we can still fit it. We labeled them, we scaled them, now we need to graph them. Because this is scaled by 5s, it's going to be difficult to use our slope of 4 and our slope of 3 and do it precisely or be accurate. So it'll be better if we just make tables, and that's what we're going to do. So for this one, we're going to use 4x plus 10. And then for the x values, we'll just look at 0, 1, 2, 3, 4, 5, and 6. Then on this one, we're going to do 3x plus 15, and we'll use those same y values, or same x values, my bad. So hopefully we know how to find the y values. We're going to take our x and plug it in to find y. So if I take 0 and I plug it in, I have 4 times 0 is 0, plus 10 is 10. Plug in 1. 4 times 1 is 4, plus 10 is 14. 4 times 2 is 8, plus 10 is 18. 4 times 3 is 12, plus 10 is 22. 4 times 4 is 16, plus 10 is 26. 4 times 5 is 20, plus 10 is 30. 4 times 6 is 24, plus 10 is 34. You with me? We're just taking the x, plugging it in, finding the y value. I want you to go ahead and pause the video, fill in this y value, or this column of y's, and then go ahead and graph it and try to figure out what the solution is. All right, let's do it together. So now that you've done it, check your answers with me. If I plug in 0, I'm going to get 15, and then 18, 21, 24, 27, 30, 33. So let's graph these. I have 0, 10, so I start here. Then I have 1, 14, 2, 18, 3, 22, 4, 26, 5, 30, and 6, 34. And of course that does go on and on and on. I'm going to go ahead and draw my line. But let's think about this. Is this going to be discrete or continuous? Can I rent a partial movie? No, I can't. So that means this one actually will also be discrete. But the reason I'm drawing lines is, again, to make it easier for us to find the point of intersection. It'll be easier if we have lines. So let's graph this next one. I'm going to graph this one in green. So we have 3x plus 15. We start at 0, 15. We go to 1, 18. 2, 21, 3, 24, 4, 27, 5, 30, and 6, 33. So just do your best to estimate those. I know they get really close to the other ones. So let's draw our line. All right, we have our two graphs. We graphed our functions. Now we need to find out for how many movie rentals the cost will be the same at both video clubs and what that cost is. What that means is find the solution. So what's our solution here? We look at our graph and we see where they cross. So that means our solution is 530. Is there another way we could have found that? Look at those tables. What is the only point they have in common? 530. That is our solution. That's the one point that satisfies both equations. So then before we're done, we just need to put this in context. 5 stands for movie rentals. 30 stands for cost. So for 5 movie rentals, both, video clubs charge $30. For 5 movie rentals, both of the clubs charge $30. So we answered our question in context. For word problems, always answer it in context. You've got a few questions to answer, and then you have the 8.1 homework to do as well.